Great, hello, and thank you for coming to the National Heart and Lung Institute's pop-up shop on heart and lung repair. My name is Dr. Jill Johnson, and I am a research fellow at Imperial College London, and I do research on the blood vessels, specifically on the blood vessels in the lung. So I've got a couple numbers up on the board behind me. The first one, 100,000. There are 100,000 kilometers of blood vessels in your body. That's the distance every drop of blood needs to travel from the heart all the way through the body and then back to the heart. The second number I have here, 250 million. That is how many hemoglobin molecules there are in each drop of your blood. So hemoglobin is the very important molecule in your body that transports oxygen from your lungs to all the tissues in your body to keep everything nice and healthy. The last number I have here, 2.5 billion. That is the number of times your heart will beat in an average lifetime. So if you consider an average lifetime about 75 years, 2.5 billion heartbeats. So that just goes to show that the circulatory system is a very, very hard-working part of the body. So I've got a diagram here of what the circulatory system looks like. So this is actually only 1/2 of the blood vessels in the body. This is just all of the arteries in your body. So you can see here the heart is right here. Then you can see the large vessels like the aorta coming up here, branching down into the smaller arteries like the brachial artery here, the femoral artery. You can see that there are many, many different sizes of blood vessels, and they really do supply the entire body. So you can think of the circulatory system and all of your blood vessels sort of analogous to the motorway system. That there are very, very large highways that you would think of like the aorta or the femoral artery, and then that branches down into smaller roads, and then finally you get tiny little lanes between the houses, and that sort of represents what the capillaries are like. So when you're driving down the motorway, really all you think about is how smooth the asphalt surface is. So that is what I've got here in this image. So you drive on a very, very smooth surface, and that's the part of the road that the car interacts with. And the circulatory system is similar to that, only the lining of the blood vessels is covered in these cells called endothelial cells. And these endothelial cells form a very, very tight sheet of cells. They're very closely bound to each other. That's what those brown lines are the junctions between the cells. And that makes a very smooth surface for your blood to flow over. That allows your blood to flow smoothly, and also all of the cells in your immune system interact with these endothelial cells. So also, similar to the motorway system, the blood vessels are not built only of endothelial cells, just like a road is not built only of an asphalt surface. If it was, it would fall apart very quickly. There are many supportive layers under the asphalt surface that you don't see but are there. So in this diagram, I've shown a cross-section of how a road is built. So you can see the asphalt layer right there at the top, but below it are many layers of different supportive structures, so different types of gravel, there's a drainage system, and a foundation for that road to sit upon. And blood vessels are like that as well. They have supportive cells that surround the endothelial cells and give them both physical support and biochemical support. So I've shown that here in this diagram. So if we look here at this arteriole, the outside of the arteriole is covered in a type of cell called a vascular smooth muscle cell. And these smooth muscle cells have the ability to squeeze, just like any other muscle cell in the body, they can squeeze. And what that does is it controls the amount of blood that is flowing through that arteriole and therefore through the capillaries that are just after that arteriole. So you know, if you go for a run or go to the gym, your face gets really pink. That's because this muscle cells around the arterioles have relaxed and allowed more blood to flow into the skin of your face. And that allows more heat to escape from your body because you've built up all sorts of heat when you were doing exercise. And the opposite happens in the winter. So, you know, if you go outside on a cold day, your skin turns a little bit more pale. And that's because your arterioles, the smooth muscle cells, are squeezing and reducing the amount of blood in the skin so that you don't lose as much heat. And that keeps your internal organs nice and warm. So the next vessels are the capillaries. And these are very important vessels because this is where gas exchange occurs. This is where oxygen leaves the blood and goes into your cells, and where carbon dioxide comes out of your cells and goes into the blood. And these cells also have supportive structures around them, these vessels. So these are smaller cells. They don't constrict like the vascular smooth muscle cells, and they're called pericytes. And they wrap around the capillaries and again support them. but they leave spaces in between them, and that's where gas exchange occurs. So you can actually see your own capillaries. If you can hold up your finger and squeeze your fingernail with your other hand, and you see when you let go, it's pale, and then it fills up and turns pink again. That's called capillary refill, and that's a physiological effect. So you can squeeze it, you can cut off the blood flow, and you know if you cut off the blood flow for too long, it would start to hurt and tingle. And then when you release it, you can see the blood flowing back into that tissue, and those are all your capillaries there. So there's another type of vessel after the capillaries, and those are called veins. They're about the same size as the arteries, but they don't have that really heavy, smooth muscle coverage. They also have pericytes, but those pericytes have a very special role. They control what your immune cells are doing. So they control immune cells leaving the body. Excuse me. So if you have an infection in your tissue, sorry. If you have an infection in your tissue, your immune cells can leave the blood and go into that tissue and fight the infection off. Sorry, I'm recovering from a little bit of an infection myself. So this final image I have for you is a picture that I took of the blood vessels in the lung. And the endothelial cells are in green. So these are the capillaries, and this is an arteriole with that heavy, smooth muscle coverage on it. And using Lego, I've made little models. So this represents an artery with the endothelial layer in yellow, and the smooth muscle layers beneath it. A capillary with those gaps that allow gas exchange, and finally a vein with smaller gaps that allow the immune cells to come out. So I'll leave those there so you can take a look at them. And that's all I have to say for my demo. I'm really glad you came to listen, and I'm happy to take any of your questions. Thank you.